Hello guys, this is Professor AutoCAD here. Since this is my first video, let's start with something easy. So we're now in May, which is already the end of spring in the Northern Hemisphere, and some of you might start experiencing the hot summer heat wave. But I've wondered, have you paid attention to this phenomenon? It's like you're walking on the roadside, a car is driving towards you, and you can see there's a reflection in front of the car, as if there's a little puddle of water in the middle of the road. But if we walk up to it, we can actually see there's no water, and the road is just the dry and hot concrete and asphalt. This is the phenomenon of the refraction of light and the total internal reflection of light. And today, we'll be talking about these two little things. Okay, refraction of light. So, when light is traveling through different media, aka substances, the traveling direction will change. For example, this is the boundary between air and water. The upper side is air, the lower side is water. When light travels from air to water, the traveling direction will change. This is called refraction. Okay, this is the normal line, the angle of incidence, theta 1, the angle of refraction, theta 2. As you can see, the angle in the air is larger than the angle in water. So we call the media with similar properties as air as optically rarer medium, and media similar to water as optically denser medium. Well, optically denser and optically rarer is actually a relative concept. It's mainly related to the difference in the speed of light in the two media. And through the refraction of light, we can actually observe, you can say, a fact, which is in optically rarer medium, the angle would be a larger one, and in optically denser medium, the angle would be smaller. This is the pattern you can see in refraction. Okay, to the next part. Total internal reflection. Well, what is total internal reflection? Same thing, let's draw our dear old boundary again. Upper side is water, upper side is air, lower side is water. If we allow a beam of light traveling vertically to the boundary from water to air, we can see that the light beam coming out directly would have no change in angle. And there's a little reflection. But as we increase the angle, we'll see that there's a refraction beam and a reflection beam, where the angle of refraction would be larger than the angle of incidence. Why? Well, what type of medium is air? Optically rarer medium compared to water, and the angle in the optically rarer medium would be the larger one. And if we continue to increase the angle of incidence, the angle of the refraction beam will eventually become 90 degrees. I made the refraction beam thicker so you can see it clearly, but I still want to increase the angle. What will happen? Boom! You can only see the reflection beam. The refraction beam has totally disappeared, and this we call total internal reflection. So, have you discovered that total internal reflection has two conditions? The first one is that light must travel from an optically denser medium to an optically rarer medium. The second one is that the angle of incidence has to be larger than a certain value, which we call it as an angle C, the critical angle, which is the one that causes the angle of refraction to be 90 degrees exactly. Let's make a small conclusion. There are two criteria for total internal reflection. First is that light must travel from an optically denser medium to an optically rarer medium, for example, water to air. Second is the angle of incidence has to be larger than a certain value, which is angle C. Great, so we've now finished the two little things. Let's get back to our question in the beginning. The car, the puddle of water that doesn't exist. This is the phenomenon of a mirage. The word mirage was borrowed into English at the dawn of the 19th century from the French word mere, to look at, which is related to mirror, also giving us the English word mirror. And this French verb, in turn, derives from Latin, mirare, to wonder at, where this wonder is just a phenomenon of light refraction. Mirage can also appear on deserts and oceans. Let's talk about deserts first. The whole mechanism is exactly the same as that we've discussed just now, as we know that the temperature of the sand can be very hot during daytime and it collects heat. So the temperature of the air near the sand will be higher. And the air has high temperature, and with the thermal expansion and contraction theory, the volume of the high temperature air would expand, and its density would decrease, making the air near the sand becoming an optically rarer medium. While the air at the sky is further away from the sand, so its temperature is not so hot, making its density to be larger than that of the air near the sand, turning it into the optically denser medium. As we know that the angle in optically rarer medium would be larger than that in optically denser medium. So if there's a cloud up in the sky, a light beam passes through the cloud, and it will be bent into a curved line as it travels from the sky to the sand, becoming more and more horizontal. Well, sometimes the angle of the light beam may exceed the value of the angle C, allowing total internal reflection to appear. The image of the cloud being inverted is reflected as if it's near the sand. But why is it inverted? Because, remember, the image was reflected once during total internal reflection. Since we know that clouds could never appear on the ground, so our brain tells us that we are observing a puddle of water that is lying on the ground, because it just makes much more sense. But is there really water? No, it's just total internal reflection. And this is the Mirage in deserts. While the Mirage in ocean is the exact opposite. The ocean water has a very high heat capacity, meaning it requires a lot of energy to rise up the temperature, meaning ocean absorbs energy. As sun shines above the ocean, the temperature of the air above the ocean would remain constant, being the optically denser medium, while the temperature of the air further above would increase, becoming an optically rarer medium. Therefore, the light being reflected from the boat would follow a similar but inverted trajectory of the one in the desert, forming an upright image. There's a note to point that most mirages in the desert are inverted, while those in oceans are upright. But why is the ocean mirage upright? There are a few explanations to this, and I'll try to explain the simplified version. There's one explanation is that the total internal reflection appeared at different positions. For example, let's take our original example. The total internal reflection appeared at this point, but some other total internal reflection would appear at another point, making the image upright. There's another saying that total internal reflection did not appear. It was just all refraction. Therefore, the image is upright. Well, what do you guys think? Just please comment down below. We'll just have a fight down there. Great. That's all for today. If you like my channel, please accent the like button. Follow my Instagram account, which is very likely to be empty for now. Subscribe and turn on the notification bell, because my channel is not just about science. I'll be doing true crimes, unexpected world wonders, classical music explanations, a bit of maths, and even maybe a bit some economics, and a lot more. There's definitely lots of things in the future, and there's something you'll be interested in. So we'll keep in touch, and I'll see you next time. Goodbye.